Hi there, we are live. Here's Jose, Carlota, and my name is Alex, and we are happy to welcome you to the new episode from the AI Upskilling framework. And we're talking together with Carlota from Microsoft and Jose, the AI MVP from Switzerland, about the level 3 building and what is there about. So the understanding from this framework,
Hi everyone.
like we see this one will be about the building, the third one, and we have done already the first one on understanding and on applying, for example, the last 2 weeks. And today we are talking about power users and developers, and we're talking about low code, no code, GPTs, whatever. We will show a lot of stuff there, and yeah, let's dive into and we are happy you joined us for this session. So, if we are talking about what people today are using somehow, let's see if we are talking about the 3 levels of this framework. What we post also this one in the chat, so you can follow this one also after this. The Harvard Business Review said that the people are somehow going from 2024 not only generating ideas right now, but also being productive. So generating code, creating new ideas, improving code, or also be creative here on this one. And what we are somehow trying to figure out during this session is as we're starting on low code, no code. So last week we talked about this one, about the co-pilots, about out of the box Gen AI experience somehow. So we can just move there and provide the information on what is there inside and how can we build this one. So later, Carlota and Jose will talk about build your own GenAI. So we do the both things. So for low code, no code, we're starting on the Copilot Studio and then moving on Azure AI, Azure Foundry, and last but not least, talking about Semantic Kernel. So in a few minutes. When we are going here to see how Microsoft defines the situation on the Copilot, Copilot Studio, and also running agents, we talk about Copilot as a new UI for AI. So we have the Copilots from the last week. So we presented this. You see this one also on the next slide. So this is from our personal productivity or business productivity. So we get only the license, activate the Copilot, and then we can use it. That's it. If we are going to Copilot Studio, then we extend the information flows, the possibilities, what we can do there also. And we talk today about these two on low code, no code, but also on developer side to run the whole agent somehow. Microsoft also defines a new way or different ways how to run this kind of engines. So you see it here. So we can just moving there and see, okay, if we are from right to left somehow, if we are going to build this one on, we need more control, visibility, and customization. Then, of course, Copilot Studio, we built an agents that a low-code, no-code platform. If we need more control, we are going to the left side to Azure Foundry for the agent service, where Carlota will talk in a minute then. Or then also, if you need the agent framework for Semantic Kernel to run your own orchestration for several agents to run them in between, then you are going for this kind of framework. And also, if we're talking about Copilot Studio, it's great integrated in all of these possibilities, what we knew from Microsoft ecosystems. And we have a lot of course, development speed. I will talk on Copilot Studio in a moment. You need more developer and more time also to create the services somehow or maintain on your own. So if you compare these 3 different levels, then you see from the left to right, of course, you have full control. If you created your own on your own, you pay per tokens, you have your, of course, Visual Studio Code or GitHub. whatever you will do this one also on Azure Foundry. So also from Foundry portal, but also on Visual Studio Code or GitHub. But you see that you can choose your own AI model, bring your own storage, you prices per token somehow, and we are going for Copilot Studio for the agents. You see that Microsoft is fully managed, or the people behind there on the backend, they manage the tooling, the storage. The price will be per message, not per token, and then the Copilot Studio agent is the platform where you build this kind of information. So you see here that Copilot Studio, and that will be our first demo somehow, enables you to create agents with a lot of connectors, with a lot of possibilities to do the knowledge inside your agents. So for example, on unstructured data, like to provide only the blob storage, and then you are ready to go. What I like most somehow since 1 year, we have Microsoft Fabric as um, central data hub, where we can store a lot of data and then use them on Azure Foundry or also on Copilot Studio. Then we will do this one in a minute. So I'm jumping right now into the demo and doing this. That's just a screenshot, but I created this one as a demo. Somehow you see we are already logged into Copilot Studio, and then we see on the left side our agent somehow. And this one I was creating this few minutes ago. So we have our agents, and then we can just go in there directly and post here our questions, starting like, hi, how are you, and so on. So you see the system is live, and you see also if the system was mentioned out, oh, my topic is greeting, and you see here, hi, hey, hello, good afternoon. That is something from the portal. What you see here is something like, okay, there are some topics I can define, and then I move on, and this topic was selected, and so on. If you're going to the overview, of course, you have to, or you can to just to give some instructions to this kind of agents. You can just add some knowledge. You can do it on your own in the beginning or also during the presentation here. The public website, SharePoint, Dynamics, Salesforce, and also some advanced stuff. Also, there will be integration on Fabric, so it will be in a shortly available. So you see here also the knowledge. So you can add knowledge if you like. That is the same. Then we are going to the tools. We can do this one to create some more tools. So featured one will be connectors to Outlook, Planner, or Salesforce. But there are a lot of more connectors, a lot of connectors you can use to everything you can calling from this one. You can also add new agent to your existing, so create one with Copilot Studio or running for the data agent on the Fabric. So how this would work is something like, if I'm going to the Fabric for 1 minute, I have in my lake here some data. Then if you create on the Fabric side your data agent, then that is one resource that is running on Fabric, and then you connect this one to your Copilot Studio and use it from this one. That is also the same if you are going to Azure Foundry later. You can also create there the connection to your Fabric and be productive from you starting on one agent and then extend it with you want with several. So how the agent is working right now. So this one, what I was creating here, you see there's some customer, but also some system topics already created. And if I'm jumping to customer, I can also create new topic, but also perhaps extend this one. This year, you need some trigger, something like, okay, the trigger can be here. If I'm clicking on this one, you see, okay, the trigger will be something you say, hi, hello, and so on. The message is, hey, hello, how can I help you today? That is the same what you see. And the greeting topics would end then. Of course, you can extend this one also, like send a message, ask a question, or also doing whatever stuff you want. What I like the most is this kind one advanced. You can just generate a Gen AI answer. So here, if I'm clicking on this one, I need a data source, of course. if I click on edit, you see that this generate an answer will be from a knowledge base, what I can do here on the web search, or also provide on advanced stuff more information to going, what kind of a LAM do I want to use? Where is my knowledge coming from? And if I've clicked on this one, you see then I can also do and knowledge only for the whole board, but also going and provide only for one topic separate knowledge. So you can just define the information here and just working on this one. Of course, you can create here whatever you want, not only an answer. What can you do here is add condition. So for example, if you want to run a condition and create more tasks here, that will be something like, okay, if this is true, then here all others do another way, or also ask a question, for example, if you like, and then provide multiple options for your users. And then you see the variable one will be this condition. I can also add new options for the user, and you see the variable 2 will be the same, the next one, and you see the condition will running through your dialog and just going there and provide the information from your style. Of course, there's activity analytics, so you have to monitor this one. And if I'm clicking on chapter, yes, I want to leave. Whenever we're going to the channels, you see you can push this as a demo website on your SharePoint, on your Teams, and also on Slack, whatever you want. So just to define the information on how you want to use this agent from different kinds of perspectives. So that was a low code, no code. I think it's time to say we want also to see what kind of in development we can also do. And then I will say we are going right now to the slides from Carlotta. And if you want to take over, the stage is yours. Please welcome.
All right. Should I share?
She was sharing already, and then she left.
Okay. I can share.
I'm sorry for this. Yeah, you can share also.
Give me 1 second. Just to complement what you said, Alexander, I think this is pretty interesting. And also the telephony and voice capabilities are incredible. So it sounds really natural. So for telephone calls, Copilot Studio is really outstanding.
Yes.
All right. And just first, before sharing, I'm going to my slide.
Or perhaps if you want, I'm sharing already, then you can just grab
we can do that. You can. So should we start with AI agent breakdown?
Yes.
Again, what is an agent? So Carlotta, welcome back. Would you like to take over? We were just about to present what is an AI agent.
Of course, and thanks, Alexander and Jose, for having me here today. Hopefully you can hear me well, having some tech issues, but hopefully that is fixed. So yes, thanks, Alexander, to kind of provide us with an overview of, building agents with a low-code experience in Copilot Studio. So just recapping a bit what we have seen from what you just showcased, an agent is no more than a language model powered entity that takes digital and or physical inputs combined with some instructions that we give to the model, and then outputs one or more actions to accomplish some goals and executes that actions to get the final output to the user. And agents might have some chat experience. We are kind of used to a chat experience, but generally go beyond typical chatbots. We can, for example, build some avatar as user experience or whatever user experience we want to provide to the final user. And they have memory. Agents have memory in a form of a conversation thread. So these are all the components of an agent. And Alexander kind of gave us an overview of all the platforms that you have in Microsoft building an agent. And what we have said is you can kind of start with Copilot Studio to prototype with the low-code experience. And then as you need maybe more control on your infrastructure, more flexibility, you might want to try Azure AI Foundry, which is the platform for developers for building agents and AI applications in general. So in Azure AI Foundry, you can first of all choose your models among a list of models provided in a model catalog. So explore all the foundation models from different providers, open source, OpenAI, etc. Test them, deploy them, and then also integrate them in your agent or your app. Evaluate your application, deploy your application, so you can basically handle the overall Gen AI ops in a single platform. And it is accessible via a user-friendly web-based UI that we are going to see in a minute, but also via an SDK for a code-first experience. So let's see. Let's go to the next slide to look at the service which we need to specifically build agents in Azure AI Foundry, which is the Azure AI Foundry agent service. Again, which is a complete platform for not just building, but also deploying, managing, monitoring, evaluating your agents at scale. It provides managed orchestration, network isolation, managed threads, and it ensures secure and scalable agent operations. So it makes you, it empowers you to build enterprise-ready agents. For enhanced agent functionality, Foundry integrates with a diverse set of knowledge and tools, including, for example, open API tools, so you can add your custom APIs to your agent, as we are going to do in the demo, but also MCP tools for interoperability with, tools provided by different platforms, Microsoft Fabric, Azure Functions, Bing Search if you want to make your agent able to search the web, for example, Logic Apps, and so on and so forth. Foundry is built to support open industry standard protocols like Assistant API, A2A, MCP we mentioned before, enabling multi-agent interactions and orchestration across multi-cloud environments. Finally, it comes with robust observability. Of course, we don't just build our agent and push it in production. We need to monitor over time the performance of our agents to ensure continuous improvement. So we need tracing, we need logging, we need evaluation, experimentation, and all these things can be done throughout with Azure AI Foundry agent service. So if we go next, the other kind of framework we mentioned before in the initial overview is Semantic Kernel, which is very tied and integrated with Azure AI Foundry, and that's why we are going to show you today how you can, for example, build an agent in Azure AI Foundry, and then build an agent in Semantic Kernel and make them connected, make them talk together, for example, in a unified architecture. And Semantic Kernel offer I would say the maximum level of flexibility and control over your infrastructure. So again, if we think about the initial visual image that Alexander showcased us, as we go from right to left, so from Copilot Studio to Semantic Kernel, we get more flexibility and more control over our infrastructure, but of course less kind of built-in connectors and pre-built feature that we can leverage. So it's the choice depends on your own requirements, needs, etc. And by the way, Semantic Kernel, I know Jose is going to talk a bit more about this in a moment. That it's basically a lightweight open source development kit that lets you easily build AI agents and integrate the latest AI models into your C#, Python, or Java code base. Jose, I know you have built already some kind of projects with Semantic Kernel. Do you have any good examples that you want to share with us?
Okay, more than an example, saying that Semantic Kernel is way more than that. It's also a full-blown AI orchestrator, and it can work with Azure AI Foundry, but it integrates basically with everything. So you from Microsoft have done an amazing work at integrating that with all the AI ecosystem. In, of course, Azure AI Foundry with Azure AI, but also with other agent frameworks, like, for example, AutoGen with QAI, with LangChain. It can integrate with all of them. So you can create workflows of agents that integrate with them. But we will leave that for later because I think you have something to say.
Yeah, 100%. The only thing I would like to clarify now, since there's lots of frameworks. If we go to the next slide, I just want to put together Semantic Kernel, Azure Foundry, another framework we didn't mention so far, but I know lots of developers are currently using, which is AutoGen to build their own agents. So how all these frameworks work together or exist together. So the thing I want to highlight is that we recently announced at Build that AutoGen and Semantic Kernel now share the same agent runtime. And they are going to share the overlying API as well soon. And again, what the teams are working on is to create an integration with Azure Foundry, which is always smoother and easier. And I'm going to show you again how to, for example, make a built-in agent, a native agent built with Semantic Kernel, and an agent built with Azure Foundry speak together. And if we go next, I also wanted to highlight as the agentic AI landscape continues to evolve, we also need we can't avoid talking about open protocols. We can't avoid, we cannot build agents which work in isolation. We really need to have our agent integrate with agents built, for example, with different cloud, with different platform, and open protocols like MCP and A2A are becoming essential for building flexible and interoperable systems, agent system. So these standards are kind of crucial as they enable developers to integrate agents across different platforms, fostering collaboration and task delegation. So Azure Foundry is committed to embracing this open protocol to ensure developers have the flexibility to build a modular and cross-platform agent system. And in particular, again, at Build, we announced that Azure Foundry Agent Service introduces a new A2A API head, enabling open source orchestrators to connect with Foundry Agent Service agents without requiring custom integration. And then Semantic Kernel supports both MCP and A2A, so it enables developers to define and consume open API-based tools within the agent web framework. I know all of this is kind of new, so I also wanted to explain a bit what is MCP, what is A2A, and what's the difference between the two. So if we go to the next slide, the Model Context Protocol is a cutting-edge framework designed to standardize interactions between AI models and client application. So it basically unifies model tool integrations across different vendors with a standardized client-server pattern in which the server exposes some service or tools that the client can request. While A2A, the A2A protocol announced by Google a couple of months ago is focused on enabling communication and collaboration between autonomous AI agents. So basically, similar to what MCP does for tool, A2A does it for agent, as it offers a standardized way to agents of different providers or built with different frameworks to talk to each other. And again, similar to MCP, as an MCP server exposes something like a card of services. So things like prompts to pre-built prompts to make it efficient, the conversation with the large language model or tools. In A2A, an agent exposes a kind of a card of capabilities for that agent. And the other thing is, rather than being mutually exclusive, MCP and A2A are complementary. And as the protocols evolve, there might be also some overlaps. For example, MCP now can be also used to get agents talk to each other as well. Okay, so I think we are ready for a demo. What do you think, Jose? Can I jump to the demo?
Go for it.
Right now?
Go for it, Carlota.
Okay, so let's see if I can share my screen. So we're going to start with demoing an agent in Azure Foundry. Okay. Can you see it, Ralph? Here we are. Okay, so here I'm in Azure Foundry. As I mentioned before, Azure Foundry provides both a low-code experience with a web page. So if you go to ai.azure.com, you find the Azure Foundry portal, but it also offers a code-first approach with an SDK. In particular, here I'm in the Azure Foundry portal, and I'm in the speech playground. Because one of the new things that we released at Build was the possibility to kind of bring your own agent to the speech playground in a way to test your agent with voice. So the agent I'm going to test right now is, here we are. The agent I'm going to test right now is an agent which manages orders for a pizzeria in Milan. So I'm going to interact with the agent, asking to order some pizzas. But with further ado, let me start the agent and show you the what's possible.
Did we lose you, Carlota?
Hello, what's your pizza menu? Okay, I think I'm having some issues with the audio. Let me see if I can show you in the agent playground. Can you still hear me?
Yes, we hear you.
Can you hear me?
Yes.
Yes.
Okay,
Yes.
perfect. Okay, thanks for.
Yes, just saying configuration
yeah,
of audio
I'm
in
having
a
some
live.
issues.
I would use text, honestly.
Yeah, I think there's some kind of issues with the configuration. So let me try with the agent playground. Sorry for all these tech issues today. So I have this orders manager agent in here. So let me show you the configuration first of all. So the agent playground is basically similar, like as Alexander showcased to you in Copilot Studio. There's this playground experience in Azure Foundry portal as well, where you can build and prototype your agent, configure with the tools, the models you need, and so on. So if my connection works, let's see if I can showcase to you my agent. So this is, again, an agent that I've built to kind of manage orders for a pizzeria in Milan. So here's the setup. The first thing I kind of configure, of course, is the agent name, but also, most importantly, the model that I want to use as kind of engine of my agent, which is GPT-4o in this case, so a multimodal model from the OpenAI family. Then I set up some instructions, which are the instructions that I want to give to the model to, kind of teach the model how to behave with my users, and also kind of configure a persona. In this case, the persona is an agent managing orders for the Contoso Pizzeria in Milan. I'm also configure here, or better, I'm also specifying to the agent that it has some tools at its disposal, in this case an API, which it can use to list the menu items, but also create orders, delete orders, etc. And there are some details, some user ID details that it might use for calling the API. And then I give some guidelines to in a way that the agent knows the kind of style and tone to use with my customers, the format of the output I want to have, and so on and so forth. So the other thing I've done is I've added this action, which is a custom API. Let's see if I can show you the configuration. Not sure why it's so. Okay. By the way, this is a custom API that I've connected here with using a pre-built connector through OpenAPI. So here, basically, I've pasted the schema, the JSON schema of my API, which includes methods for create orders, delete orders, and things like that. And then there's a few model settings configuration here, like temperature, topi. So of course, this is just one of the actions available. You can add also things like code interpreter, so a sandbox to execute the code that the agent generates, and much more. So let me interact a bit with this agent. So I can ask things like, hi, what's your pizza menu? Okay, so as you can see, it is using the OpenAPI tools to get the menu details. So normally it takes less than that. I'm sure that with some connection issues I'm having, it is taking a bit longer. So hopefully I can showcase the output to you. Okay, I will just go ahead because I'm having some connection issues. Site unavailable. I'm sure it's kind of related with some connection issues I'm having. So the live codes are not with me today. But the other thing I wanted to let you showcase to you is among the tools we have at our disposal, there's also this kind of this tool, which is connected agents. Basically, with connected agents, we can connect another agent as a tool in a way that instead of, I don't know, for example, if I want to let this agent also answer questions about the Contoso Pizzeria, things like, home delivery services or dining services. I can kind of upload, for example, some data, a database, or some on-premises files with this information with file search as an action. Or if I want to kind of improve the performance of my overall system, I can also have a sub-agent which kind of care about all the questions related to the Contoso Pizzeria services, and keep the main agent as the one responsible for creating orders, manage orders, etc. And then delegating specific questions to the sub-agent, which I connect as a tool. Okay, so I think we can come back to the deck. And going.
All right. Should I take over this slide? All right. So
Yes,
let's take a look to the semantic. Let's take a look to the semantic kernel ecosystem. As Carlota mentioned before, is enterprise AI framework for implementing anything on AI orchestration for .NET, Python, and Java. Its motto was plugins, planners, and personas, but since me to 2023, it became plugins and personas because LLMs could plan on itself. More clearly said, they were able to do tool calling, and that has been a game changer since then. And now it's kind of engraved in everything on the AI wall because basically everybody copied the OpenAI API. So planners are no longer in there. Next, we have the process framework, which is bringing together the world of AI orchestration and business workflows, which is at the moment experimental, but super, super powerful idea. It's being developed in Semantic Kernel as a separated experimental framework at the moment. I contributed a bit to it, so I'm pretty happy about that. But I hope it will see the light in the next following month. So if we go ahead, there's other similar components. So one is the base layer, which was added these Microsoft extensions for AI, which is taking over some basic functionalities, and instead of putting them into another framework or inside semantic kernel, they are being made part of the .NET framework, which I think it's great. If we can click next. Okay, yeah. You can click next on everything, and I keep explaining. Then it's a layer of abstractions that supports everything, and then it's the semantic autogen core, which is this was announced by I think October, November last year, 2024, and this is the layer that semantic kernel will become the core of autogen, or both of them are going to be integrated in a single agent framework. Then is the MCP, which since a few months, I think March this year, semantic kernel is already supporting. You can use it. It's super, super easy. It's built on top of the official SDK for C#, at least the part I know, which is C#. I'm a C# developer. Sorry about that. And this is working brilliantly. I got a blog post on LinkedIn on how to build that and integrate that as a Azure, as a Microsoft Aspire, and it works really wonderfully well. Then we have Agent, which went GA not so far away in time, like 3-4 months. So it's general availability, so we can create agents which will not change or break, which at the moment it was experimental since release on 1.0 in December 23. And then we have A2A, which has been announced, but it's already being developed there. I think I have not seen any example yet. I don't know if there are. And then orchestration. Orchestration is agent orchestration. This is what the team has been building, and they released it like 4, 5, or 6 weeks ago for implementing the workflows of AutoGen. So you can implement the AutoGen latest and greatest workflows, agentic workflows, I mean, inside semantic kernel. Carlota, correct me Anything you would like to add? All right, then we can go next. Hello? Alexander, are you sharing or I'm sharing? You
No,
can,
Carlotta
somebody
is
can
sharing
advance.
right now.
I'm
so
sharing. Sorry.
Yeah. One thing Rakesh asked, what about troubleshooting? I can respond. You have .NET logging there, so you can put your favorite logging platform, observability platform, and you can check that perfectly. There's some agentic logging platforms, right? And as far as I know, Azure Foundry has also a very nice layer of observability for AI agents and everything in regards to what happens in the cloud. So you can log what happens in .NET and what happens in the service. It depends on the cloud infrastructure you're using, which, as I mentioned, Microsoft Semantic Kernel is integrating with basically everything. I hope that responds your question, Rakesh. Carlota, back to you.
Yeah, I just wanted to added something about, I've mentioned before that you can kind of connect an agent in Azure Foundry to delegate some tasks to a sub agent. So the question I kind of get sometimes is why we might need to connect multiple agents. We cannot just build one single agent and that's it. So the thing here is that single agents can solve a wide range of problems, of course, are simpler to implement. So the recommendation is to always start with a single agent. But multi-agent system should only be and multi-agent system should only be used if a single agent is kind of unable to solve the challenge, to handle tasks that maybe involve more data, diverse roles, or complex workflows. And the reasons why you might need to consider multi-agent architecture can be kind of summarizing these 4 points in here. First of all, to get more flexibility, because agents can be reused across different workflows or composed into new system. Scalability, because tasks can be kind of distributed among multiple agents instead of overloading a single one. And more agents can handle, of course, more tasks simultaneously without bottlenecks. The other reason is specialization. So agents can be fine-tuned for modular tasks or domains, improving overall performance and making the system easier to build, test, and maintain. And finally, performance, which is something I also mentioned before, because review. Of course, it's balanced between lots of factors and things, but generally speaking, for like huge workloads, we have seen a performance increase by using multiple specialized agents. Do you want to go over the group chat?
Sure. Yeah. To what a bit what Carlota was saying on where multi-agents should be used in single agent,
yes,
I would add that as well. The interaction between several agents brings a lot of benefits. So if can you click next? Okay, I'm going to share myself. Okay, yeah. So you can see the human. Sorry about the text. So on the left picture, you have a human on a keyboard. He makes a request to an agent, right? And the agent is a writer agent. And then the agent on the right side is a reviewer agent. And the first one does the task, writes, for example, a text or even a code, and the other one reviews it. And then it gives back the feedback and suggestion for improvements. And then the writer takes the feedback, uses it, improves either the text or the code or whatever he's doing, and then gives it back. This is called the critic workflow. There is, I think, 2 or 3 or 4 papers for that. And this improves the workflow dramatically, but dramatically. So it's not just when try, it goes until it's kind of a quality check, because when the critic says, oh, this is good enough, now it approves. So your code is building, the tests are passing, okay, now it's good. It may take some time, but that's the power behind agent collaboration, and just that with 2 agents. So do you want to use multi-agent after this? Well, there's a studies that show that, for example, GPT 3.5, this is a study made in 2023 about August by the responsible of deep learning.ai, and there these reach like 49% on a human evil, a coding benchmark. And with using multi-agent, maybe with a bit more complexity than we're seeing here, it reached 97% accuracy. So a boost of 47% of capabilities. So depends on your task. You may want to use multi-agent, just saying. That's it for me. Back to you, Carlota.
Yeah, so we kind of covered the next slide, but I just wanted to add that what Jose just showcased is a kind of multi-agent orchestration, which is more, which gives more flex, kind of good if you it's an LLM-driven orchestration, so it's kind of the LLM based on some trigger instructions we specify that decide which agents to call for which query of the user, while with the orchestration pattern, like the group chat that and which are provided by Semantic kernel, you can specifically control the order in which these agents are invoked, how many times they are invoked, for example, or what parameters or values that are. And you know, there are some specific use cases where you want to design a deterministic and predictable execution pattern in which the agent works. And the group chat is just one option. There are multiple kind of orchestration options in as can you hear me?
Yes, we can hear you. Let me try something. I was sharing my screen, so perhaps we switch to my screen back, and then turning your sharing away, so we have your audio clearly going through.
Alex, you can try to share my screen.
Yeah, go ahead.
Because I will be next, so that would be perfect.
Yeah, that's already changed.
Oh.
So let's go.
Okay, so it's you sharing then. So on my side, following up with what Carlota said, these connected agents gives a lot of power. So for example, here, what we're seeing is a researcher multi-agent architecture, which is done, well, can be done in Semantic kernel, but can be done with any other. So we could use an agent from Azure AI Foundry, right? In this case, I have one which is embedded in a plugin, a researcher, which has web search, scraping, summarizing, query generation. Then we have a document writer to create a document, write a document, read document. And then we have a critic, which it does not do the critic, so it divides the work. So it parallelizes to 3 helper reviewers. One reviews the SEO, other the fact checker, other the translator. I have a demo where I do like 9 reviews in parallel, and they finish and they come back. And once all they are done, the main critic summarizes all the critic and provides it to the commander that delivers it again to the document writer to rewrite it according to the feedback. This approach, which was shown before, is one of the best patterns of multi-agent orchestration. It's kind of divide and conquer, and specialized agents are a lot more efficient than generalistic agents that do it all because they have focus like humans.
That's nice.
I think it is, and it works. It's kind of we are stopping to be developers and beginning like to be managers of agents, right? It's kind of interesting.
Mhm. Let's talk next about the
Yeah,
patterns.
and the other good thing is that you have lots of different orchestration patterns, right? So we have seen the group chat, for example, but there's several multi-agent orchestration according to your requirements. We have the sequential one, for example, where agents are connected in a way that the result of one agent goes to the next one. We have concurrent orchestration where the agents work simultaneously. We have the handoff where we have that dynamically passes control between agents based on context or rules. We have again the group chat. We also have the Magentic one, which is inspired by the AutoGen framework. We have the custom workflows. So we have lots of choices and possibility.
Just
so
to add there,
I know we don't have lots of time. Yeah.
May I? Just to add there, I really love the handoff. So the handoff is especially super cool for me because it means that one agent can decide who goes next. So if according to the task, so it's up to the agent to decide where do we go. I think it's super cool because it's really powerful. It's not bound by any predefined workflow. It's kind of a dynamic decision based on the agent itself, right? You can predefine it a bit, but each agent can decide, okay, who goes next. I think that's pretty cool. Back to you.
Right. And just to come back to our Contoso P3. Yeah, just to come back to our Contoso P3 example, I wanted to quickly showcase to you the code I've used to kind of import the agent I've built in Azure Foundry and make it work with other agents which are natively built with Semantic kernel. As you can see here, I've specified an Azure AI agent ID, which is the ID, the unique ID of my agent in an environment file. So then I can kind of build this architecture where I have 3 agents. One is the welcome agent, the customer's welcome agent, which is the one which greets customers and provides information about the restaurants. And I've added here some instructions and some information about the Contoso Pizzeria itself. And this is not with Semantic. Using this Azure Agent Foundry class. And then I have a third agent, which is my allergen checker agent, which checks order requests and identify potential orchestration, which is one of the orchestration we have seen in the graph. And then we just start the runtime and see the result of those 3 agents working in parallel. Okay, so I think we can, that was it. I think we can come back to the deck as we have a few minutes to kind of wrap up. And as we wrap up, I want to take a moment to connect all the dots because we have talked about lots of stuff today. And what you see here is kind of the full ecosystem that supports building intelligent and scalable agents using Azure Foundry and Semantic Kernel. Data. At the center of this ecosystem, of course, we have the Azure Foundry platform with the Azure Agent Service, bot service channels like Teams, Slack, and emails, so you can deploy these agents to work on these channels. Then on the bottom, we have Semantic Kernel running in Azure Container Apps, which plays the role of the multi-agent orchestrator, and we have seen the different orchestration patterns we have. And supporting all of these, there are automation tools like search and also interoperability through open API-based external APIs, MCP server, A2A, and the new kind of and the new protocols.
That's cool. That's nice. So if we are talking about this kind of implementation, what Carlotta was saying there, we need to figure out that there are some best practices there. So we can just move on also on this kind of implementation then. So just to figure out, you have to do some monitoring, governance stuff, and evaluations. And also the question to the both is, what is about the tomorrow AI landscape? Can you figure this one for us?
I can talk a bit about that. I mean, I was talking at ECS like almost 1 month ago, so and more or less it kind of stays, right? So I was proposing that there will be a layer where Semantic Kernel is creating the core agent layer, right? That was what I was mentioning, and that would be kind of the base. So my best thing here is a common framework, which now it's published. So they publish in the Semantic Kernel office hours. Now it's called, I think, office hours of. I don't know if the name of the team will change because a lot of things have changed. So they are now a single team, AutoGen and Semantic Kernel. So good things are happening with these core AI changes. Core AI is the new division of Microsoft, which is doing everything in AI. So basically, my thoughts there were, Microsoft extensions for AI will stay. This is acquiring everything which is super basic and core is going into the framework, right? So it's a NuGet package, but it's part of the .NET framework. So it's acquiring capabilities that before were in Semantic Kernel, and Semantic Kernel is adopting them and changing. So Semantic Kernel stays. Semantic Kernel will acquire agent, single, and multi-gen core orchestration and the process. And AutoGen, and I don't know if this, sorry, can you go back? This will be renamed as agent framework, or it will be a separate framework which can be still used inside Semantic Kernel. So I think that's the best of all worlds. And we can do what everybody has been wishing before. I want to do AutoGen, what AutoGen can do, but in production in a reliable way that what I build doesn't break in 1 or 2 weeks. Because, for example, me myself, I wrote a course about AutoGen, and 2 months after it was deprecated because the UI was not matching anymore. Still, a lot of people are doing that, but AI is evolving a lot. And on top of these, we can create a .NET application, Copilot Studio. Yeah, we can do Copilot Studio with, so we can create an agent with Semantic Kernel and deploy it in Copilot Studio. So we can also have the best of both worlds there. We can deploy that in GitHub Copilot, or at least it's announced, and use A2A and MCP, and of course, Foundry. So that's a bit what I see at least at 1 month or 2 months view. What do you think?
Okay, that's great. If you want to go for semantic kernels, fundamentals, and concept of AI orchestration, there's a LinkedIn information here also. And what we also wanted to share, what is Carlotta is doing here about the Foundry devs. So, do you want to say about the communities?
Yeah, just a couple of words. Global AI is a wonderful community. Enables you to kind of connect also in person. We also have a couple of virtual digital communities that you can join, which are kind of focused on the Azure Foundry platform. So if you kind of if you are getting started, or if you have some existing project in Azure Foundry and you want to kind of get support from the community, but also the Azure Foundry product group teams or other product group teams in Microsoft. The first link makes you navigate to the two communities we have. One is on Discord server, if you are kind of familiar with Discord. We also have some roundtables there. And the other is a forum on GitHub. And then the second link is just the link to the code that I've showcased to you for the concurrent orchestration with Semantic Kernel of the 3 agents built with Semantic Kernel and Azure Foundry.
That's nice. Thank you very much. And also, we wanted to share the AI agents for beginners. So if you are new to this kind of topic, you find a lot of information on AKMS, AI agents beginners. And that is some free courses from Microsoft. And that is a great stuff that you are building there. So.
Yeah, 100%. This is a great resource as well as you go through your agentic AI upskilling.
Okay. Thank you very much. So that is a great final sentence from Carlotta. So we are now on the outro. We have done the building one for power users and developers, showing no code, low code, and also developers on Azure AI Foundry with a lot of demos. And I think that is something what you happen here on the Microsoft perspective, also from build your own GenAI solutions. And we will just thank you all for joining us today. Thanks to Carlotta from Microsoft and Jose, the Microsoft AI MVP, as also myself. Thanks for joining us. It was a pleasure to have you both here. And yeah, have a great day. See you next time.
Thank you, Alex. Thanks, Carlotta.